All right, so now we're going to do division. We have done adding, subtracting, and multiplying polynomials. And then we also went into factoring, which is breaking things, dividing things into smaller numbers. But this is actual division, where we're going to take two polynomials and we're going to divide them, okay? So there's two types of division. The one we actually do more often is synthetic, but there is a long division in case you need it. And that is a method used to divide polynomials similar to the way we divide numbers. So I'll review long division with you. That you did back in elementary school. And then synthetic is actually a shortcut. It's a nice different way to organize division that usually goes faster and smoother, and it's the way that we divide polynomials as long as the divisor is in the form x minus a number. Okay, and we'll talk about how to make sure it's that when we get there, okay? So the first thing I want to do is I want to review long division, so that we can relate it to our polynomials. That's actually the harder, I think it's typically kind of the harder way to do it. Some students, once they get used to it, they really like to use it, but it's just a little bit different. It takes a little bit different thinking power than synthetic. So let's look at this one, okay? Here's the problem. 4x to the fourth plus 5x squared minus 9x plus 18 by x squared plus 2x minus 4. So what we're going to do is we're going to set that up like a long division problem. The only thing I want to point out is that it jumps from x to the fourth to x squared. So in the polynomials, we actually have to add an x to the third term. You've got to have a place value for every term. So because it goes from the fourth down to the second, we're going to squeeze in an x to the third, and we're just going to put a 0 with it. So even though there's not one there, we put a 0 because 0 means nothing. But it holds a spot, and you'll see why when we start setting up the division, okay? You need a spot for every exponent when you divide, whether it's synthetic or whether it's long, okay? So we're going to squeeze a 0 into that problem. And that's what that says right there. Include a 0. All right, so before we divide, let's just go over long division back in elementary school. If I have 263 divided by 19, okay? Then when I make my box, I put the 263 inside the box. I put the 19 outside, just like we did here. The longer one, or the first one, is on the inside of the box. The shorter one, or the second one, is on the outside. How many times does 19 go into 26? We just look at the first two. Well, that only happens once. So then you multiply. 1 times 19 is 19. So then there's a phrase that I use when we start doing this. Draw the line, change the sign. Okay, so when you draw that line in order to combine them, change the sign. In this case, it's subtraction. In these, it could switch either way. So then we subtract. So we subtract, I carry, that's 1, that's 73, because you bring down that 3. It's going to be the same process here, okay? How many times does 19 go into 73? Well, if that's hard to think of, round that to a 20. How many times does 20 go into 73? Well, that would be 3 times, because that would be 2 times 3 is 6, and so that's just a little bit under that. So then I multiply. 3 times 19 is 27. And then 3 times 1 is 3. Add that 2 is 57, okay? Draw the line, change the sign. So when I subtract, I carry, or I borrow and carry, so I get a 1 here and a 16 there. So as long as this 16 is smaller than that 19, then I've done everything right. And we could write it as a remainder, but really, mathematically, you also can write it as a fraction, and that's what we're going to do. So it's whatever the remainder is over whatever we were dividing by. So that was 16 over 19, and that doesn't reduce because 19 is a prime number. So this answer is 13 and 16 over 19. And that's the same method or same thought process we're going to do here, okay? So this is already set up. I already mentioned that we need to put a 0 for an x cubed spot so that as we multiply, we've got a place for every exponent because we're going to need one as we start multiplying, okay? All right, so the way we set it up is we always divide the first term and the first term. Okay? We're always going to divide the first terms in order to figure out what is going to go here. So I'm going to divide 4x to the fourth by that x squared. Okay? And that's going to set me up with this process of getting my term and then multiplying it in. Getting my term and multiplying it in. So when I divide that, I get 4x squared. So that's the first term of my answer. So now I take this 4x squared, and just like I multiplied whatever I had up here by whatever I have out here, I do the same thing here. I take this 4x squared, and I multiply it to each of those. So 4x squared times x squared is 4x to the fourth. 4x squared times 2x is 8x to the third. And 4x squared times 4 is 16x squared. Okay? Then again, I mentioned draw the line, change the sign. So when I draw this line, I'm going to change all of their signs, okay? So let me do that in a different color just so that we make sure to see it. So draw the line, change their signs. Okay, so when that happens, these cancel out. That's what you want. You always want the front to cancel, and then we'll just combine the rest. Negative 8x to the third, that is a negative 11x squared, and bring down the negative 9x just like we brought down the 3. Once we did one row, now we bring down because we're going to do the next row, okay? So then, again, we're going to divide first term by first term. So negative 8x to the third divided by x squared. Okay? When you divide those two, you get a negative 8x. Now that I know that term, I multiply it by each of these to get 3 new terms to combine. So negative 8x times x squared is negative 8x to the third. That's what we want. We want those to match. Negative 8x times 2x is negative 16x squared, because x times x is x squared. And then negative 8x times 4 is negative 32x. Okay? Now, again, we're going to draw the line. So draw the line, change the sign. So draw the line. Now, since all of these are negative, that's actually going to change all of these to a positive. So again, it isn't always subtraction, it's just whatever the sign is, you change it to the opposite. Negative 8x cubed and positive 8x cubed cancel. Negative 11 and positive 16 is a 5x squared. Negative 9x and positive 32x is 23x. And then we have to bring down that last term, which is the 18. Okay, so again, now that we have a new line, the last thing we're going to divide is this first term by the x squared. So that's 5x squared over, or divided by x squared. So when you do that, the x squareds cancel and you just get a positive 5. So now let's multiply that term by these 3 and we're almost done. Okay? 5 times x squared is 5x squared. 5 times 2x is 10x. 5 times 4 is 20. All right, again, I didn't put pluses there because I'm going to change the signs anyway. So draw the line, change their signs. They're all positive, so they all become negative. So 5x squared and negative 5x squared cancel. 23x and a negative 10x is 13x. A positive 18 and a negative 20 is minus 2. Okay? So just like we had something left here, if we have something left here, there's nothing else to bring down, so we're done with the problem. Just like we wrote a fraction, the remainder over what we were dividing by, we do the same thing here. We just add, this is our numerator, 13x minus 2, over, the denominator is this, what we were dividing by, x squared plus 2x plus 4. And that is actually how we write that final answer. It looks huge and unnecessary, but that's actually, you get each of the terms, and since this was remaining, you just write it as a fraction, which is what we did here. Okay, and you don't have to reduce or anything like that. Okay, so that last line down here, it says write the result. This is what we're talking about, so I'm not going to scroll it. This is really what? This is actually the final answer. This is the final result. So if you want to write this down here on that line, you can, but you don't need to because the answer's here. That's why it's set up like that, so you can see it, okay? So now we're going to go into synthetic division, which actually is faster. There are some similarities, but it's a different process. You don't have to worry about exponents and stuff. So, all right. There we are for now.